ISEA Cafe. And thank you so much for your flexibility as we continue in these times to figure out how to do hybrid events, which even 4 years after they started continue to be kind of funky and weird. So thank you so much whether you're joining us in person or online. We're really excited about today's cafe. I have had the pleasure of hanging out with Art in a couple of, thank you for everyone. I have had the privilege of hanging out with Art in a couple of instances. We've chatted a few times in preparation for this, and he is a wealth of knowledge and information. We're gonna have a great time today, and I'm going to, at this time, I'm gonna hand it over to Art, and go ahead and tell us a little bit about yourself and what got you into this work, and take it away whenever you're ready.
Okay, we good to go?
No. How do we do it? That's how we do it.
This needs to get muted.
All right, Art, go ahead, take it away.
Hi, okay. So thanks, Rachel. Again, my name is Art Hirsch, and I'm from the Michigan Sierra Club and the Michigan Microplastics Coalition. First of all, I want to thank Rachel and the Inland Seas Education Association for the interest in the microplastic topic and coordinating this presentation. I also want to thank those of you in the audience who are attending the Zoom talk and discussion, and I appreciate your interest in the microplastic pollution issue that's threatening our Great Lakes. I'm sorry that I can't be there in person to give this talk. However, I hope to meet many of you this summer when I get my complimentary schooner ride. I'm honored to be asked to give this presentation to the association, which stands for the same things that I do personally, such as fostering and promoting Great Lakes resiliency for future generations through outreach and education. And we also share the same values to protect the Great Lakes by stewardship, education, diversity, integrity, and passion. Thanks again for being at this presentation this afternoon. Let's see if I can get this forwarded. It was working, come on. Bear with me. I'm trying to advance the slide here. There we go. Before I give my presentation, I would like to acknowledge and pay respect to the Michigan Indigenous Tribal Nations, whose lands and waters we gather and live on today. This land holds a rich cultural heritage and history, and it is with honor that we gather here today. I would like to acknowledge the indigenous peoples such as the Potawatomi, Ottawa, Ojibwa, Chippewa, and other tribes who have lived and thrived on this land for thousands.
Well, lost the voice.
Hey, Art.
Yeah.
Oh, good. Never mind. You're good.
Okay.
Good.
Okay, we're good, right? Okay. I'm getting some background noise. I'm not exactly sure if everyone's on mute or not, but anyway, just thought I'd let you know. Come on. There we go. So over the past 10 years, microplastics have become recognized by scientists, researchers, environmentalists, and some legislators as a significant environmental pollutant to the Great Lakes. Unfortunately, many legislators and regulatory officials and the general population in the Great Lakes area know little to nothing about microplastics and its problems. It's important to note that the state of Michigan is not monitoring the surface, drinking water sources, and groundwater in the entire state of Michigan. This is a situation that has frustrated me and really caused me to pursue this microplastic activism. The microplastics issues that I'll be discussing this afternoon is the result of overproduction and poor management of plastic waste within our throwaway society. Microplastics are considered to be, by the state of Michigan and the EPA, as an emerging water quality pollutant. So, well, what does that really mean? At least in my interpretation of that, means that there's no regulations to control the discharge of microplastics into the surface water of the Great Lakes. There's no surface water quality or drinking water standards that have been established for microplastics. There's no risk-based concentration or no risk-based concentration that has been known to cause health or ecological impacts at this particular time. However, there has been a lot of research being done in this, and I plan on sharing that with you later on in my presentation. And finally, there's no aggressive, proactive management strategy that's been developed in the Great Lakes and in the state of Michigan to protect water quality and the public health. This is kind of a snapshot of what I'm going to be talking about today, kind of a microplastics 101. There's a lot of things I'm going to be touching upon. I'm trying not to get too much into the detail unless you have questions, which would be great to address. I want to give an overview of really what microplastics are, the extent, the pathways from sources to the Great Lakes waters. Controls and regulations, be talking about that, and some proposed legislation that I have at the state of Michigan, and also things that are happening at the federal level. I'm really interested to hear your thoughts and concerns and questions at the end of the presentation. So my goal is for you to become better aware, educated, and become concerned to take action about this particular water quality pollutant. So several themes here. I think, as we all know, being from the Midwest, along the Great Lakes, is water really is the essence of all things in Michigan. Microplastics is a very, very complex issue, which I'll try to relate to you during my presentation. There are real environmental and human risks associated with microplastics that are just becoming to be realized now. There's huge data gaps that I'll talk about that need to be filled by research, many unknown, so to speak. Recycling will not solve the microplastic problem. And this is a very important message. The problem is going to get worse if we do nothing. And I have some graphs to show that, the amount of plastic being produced is enormous. So during this presentation, I don't want you to be overwhelmed. There's a lot of stuff here, a lot of things that are going on in the microplastics world, so to speak. The point I want to make is there's something that we can do about this. So don't be overwhelmed by this presentation, please. So I grew up on the shores of Lake Michigan. I went to Michigan State University in Fisheries and Wildlife. Was my major. I also have. Can somebody be on mute, please? Put it all on mute. Thank you. And so then I also got a master's in environmental engineering from the University of Colorado, primarily in water quality issues. So living on the lake almost all my life, I live in Pentwater right now, just south of Ludington. And I also live right now in Boulder, Colorado during the wintertime. But this is really what I've experienced in my lifetime, really affecting Great Lakes in terms of pollution, how Lake Michigan has been abused. And this is just a laundry list of pollutants that I'm not going to go through in detail, but many of you recognize these historically, from all the way to raw sewage, to invasive species, detergents, bans, combined sewer overflows, Asian carp, and PCBs, which is a huge problem back in the 70s and 80s. And now we have perchloroalkyl substances called PFASs. And to add to the list now, microplastics. The point here, we need to do a lot better in terms of managing Lake Michigan and the Great Lakes. It's just not something you throw your waste in and hope that it will dilute and not cause a problem. And we have seen these problems historically for many years. So when people think about microplastics, people think about plastics in the environment, and especially the aquatic environment. A lot of times they'll think of the 5 gyres, these circulations of plastic material, such as this one right here, taken from a high altitude here, really showing the gyration of the currents here in this particular North Pacific gyre, which is the largest one. But what happens is that accumulates a lot of trash coming from the United States, Japan, Southeast Asia, etc., and creating these huge plastic mats that extend thousands of square miles in the oceans. Well, just like there's a circulation pattern, if you will, in the ocean, there's one in the Great Lakes. And it really influences the distribution and density of the microplastics and plastic materials that are in the water and accumulate on the beaches. So you can see here in Lake Michigan, you basically have a counterclockwise motion of circulation here in Lake Michigan. Again, very similar to Lake Superior and also Lake Erie and also Lake Ontario. So again, this has a profound effect, because what happens is that you don't have a centralized gyre just circulating. So because of these circulation patterns, a lot of the plastic material ends up on the beaches and shorelines of the Great Lakes. And this over here at the bottom right is just kind of an intensity loading of plastic, mostly coming from stormwater discharges, but just overall plastic loading that occurs into the Great Lakes. And it's not surprising that Lake Michigan gets its share of abuse from Milwaukee, from Chicago, Indiana, etc. And also you see the influences of Detroit, Cleveland, and Ontario in terms of its heavy plastic loading that occurs in the Great Lakes. So plastics. I have to talk a little bit about plastics to really set the stage of microplastics. Basically, plastics are basically the parent material, if you will, the precursor to microplastics. And so these are the uses of plastics that we have in our society. And the problem is that plastics is so integrated into our personal supply chain, it's impossible to stay away from it. So here's kind of the examples of the plastic material usage that we have here in the United States. The number one use of plastics are single-use plastics, from anywhere from bags to single-use plastic bottles, such as drinking water. The second is construction, either piping, insulation, styrofoam fittings, etc., are all incorporated into the construction area. Surprisingly, our clothes is the third most used plastic. A lot of our clothes are synthetic, polyester mostly. Very few of wool, natural fibers. So this is a surprise to me when I was starting to do this research. Then we get into basically just miscellaneous types of plastic materials that we use throughout our life here. Automotive is huge in terms of a use of plastics because of the lightweight and resiliency of the material. And also we get into electronics and industrial applications. So I'm not trying to diss plastics. Plastics are a necessity in our life. However, the trouble is that we use too much of them. So here's just a snapshot of the type of plastics that are used in manufacturing. There's literally hundreds, if not thousands, of different types of plastic materials. And what I did on this particular shot here, this screen, is really identify the major ones, the ones that we find in the water, the ones that we find on the beaches, remnants of milk jugs and shopping bags and rope and water bottles and medicine bottles and materials such as styrofoams. So this kind of gives you a laundry list of the type of plastics that we're dealing with that ultimately make microplastics. So that's the trouble. The trouble is we have too much plastic, we manufacture too much plastic, and we don't have the knowledge or the impetus to really manage it. So this is an important graph. It kind of shows you why we can't wait. We have to do something about the microplastics because the growth of the parent product, plastics, is just increasing enormously. On the left-hand side, the y-axis is really US tons of plastic waste. In other words, you can consider this to be waste generation. And over on the right are years from 2060 all the way to through 2020. A couple things to notice about this is that you can just see that things just took off in regards to the use and development of waste for plastic materials in the United States. It's completely huge. It's about 35,000 US tons so far every year. It increases at about 4 or 5% a year, which is pretty alarming. One of the things I wanted to point out here is this green, recycled. And recycling, as I mentioned before, is not going to solve this pollution problem. You can only about 9 or 10% at best of the plastic waste generated really gets to be recycled. So when companies and you hear propaganda saying that we can recycle our way out of this problem, you can see that we can't. And by far the largest way of getting rid of the plastic is landfilling. So we have a gap right here. And this is ultimately the plastic material that ends up in our environment. Plastic materials are made out of what we call endocrine disrupting chemicals, and they're also carcinogenic. We all know that plastic's really made out of nasty material, but their endocrine disruptor chemicals are really toxic to our hormonal balance as human beings and also wildlife. It's toxic to reproduction. It damages our fertility, and it even impacts the unborn child in vitro. So there's a few types of additives here that I've got on this slide, from bisphenol to phthalates to alkyl phenols, PFASs. All of them have a different particular function in plastic. Either it gives it more flexibility, it gives it strength, it gives it color, and those sort of things. And this is really one of the major problems associated with plastics, is really these additives. I was looking at some of the data, and there's over 13,000 chemicals that are used to manufacture plastic. And that's an amazing number of different weird chemicals that are used to manufacture plastics. Also, I noted that the fertility rates in the US have decreased 30% over the past 35 years from work done in New York. So I just kind of wonder in my head, is there a relationship between this lack of fertility and our exposure to plastic? Let's talk about the Great Lakes here. Huge amount of plastics enter the Great Lakes every year. 22 million pounds of plastics have been estimated to enter the Great Lakes. And Lake Michigan is number one, 11 million pounds per year, followed by Lake Erie, Ontario, Huron, and Superior. So most of the plastic waste material that we find on the beaches really is plastic. And there's no surprise that these huge metropolitan areas are a major contributor to this plastic. So what are microplastics? We've all read about them. We've all seen them, but really, what are they? What are microplastics? Well, there's two types of microplastics. First of all, the universal definition is it's plastic material that is less than 5 millimeters in diameter. So those of you who might remember your metric system, that's right around 3/16 of an inch in diameter. So that's the physical dimensions of a microplastic. The primary type microplastics are those microplastics that are manufactured specifically at that size, which is less than 5 millimeters. And these are mostly done for production purposes or product purposes, such as pellets, which we'll call nurdles, which are precursors to plastics, toothpastes, cosmetics, industrial uses of microbeads for paint removal or rust removal in industry. So again, those are kind of a summary of what a primary microplastic is. But a secondary one is probably the ones that we're most familiar with to a certain extent, is really noticing that you get a water bottle that's been laying on the beach, and all of a sudden it starts breaking down because of the UV sun radiation, weathering, wave erosion, and just the wind, basically creating these microplastics. They're making smaller and smaller and smaller sizes of microplastic materials. So these are probably, I think, not the most common, but this is the one that we have a harder time controlling. There's another type of microplastics called nanoparticles, and I'll talk a little bit about this later on, but these are the type that are like about the diameter of a hair. This is probably the most toxic form of microplastics in the environment because they're able to get into the blood, the lungs, and also be able to penetrate the cell barrier and actually get into causing problems within the cell structure. There's basically 5 different types of microplastics. We have the fragments, again, those secondary type plastic materials. We have pellets, which these are like nurdles. These are like used in industrial applications. And then we get into film. And so, what is film? Well, film is your potato chip bag. It's your Snickers bar type wrappers. That's what the film is, and it's made out of plastic. And then we're all very familiar with what styrofoam is. It's a very prominent type of microplastic in the Great Lakes. And then we get into microfibers. Microfibers is the #1 type of microplastic in the Great Lakes. It's the biggest problem. A quick snapshot of just a distribution of microplastics in the Great Lakes. One of the things that happens is that throughout this region, the Great Lakes region, nobody is doing routine monitoring of plastics. This is work that's been done by Dr. Mason in 2014. And this is the most recent information that I could really find to date. And so it's reflective of the lack of monitoring that's being done in the Great Lakes. But at least it gives you a snapshot that, first of all, it's present in all the Great Lakes. And it also has a tendency to accumulate as we go downstream to the Great Lakes towards the St. Lawrence Seaway, as we go through and get the influence of Detroit in Lake Erie, and also as we get closer and closer to Lake Ontario, in on Lake Ontario, which gets the highest concentrations of microplastics of all the Great Lakes. You'll also notice that Lake Superior has a relatively high concentration of microplastics. And this is due to aerial deposition and the low residence time of water in the Great Lakes, or in Lake Superior, which is about 200 years. So at least that gives you a snapshot of the distribution of microplastics in the Great Lakes. So I'm going to start talking about sources of microplastics and also pathways. So where does all this stuff come from? Tires. Tires is a huge, huge microplastic source. It's probably the biggest source in California right now because there's so many tires in California. And what happens is that these tires basically break down and wear off, and they end up on the pavement. And then when it rains, it gets into the stormwater system, or it becomes airborne. Sources is also textiles. And this is the part that really affects me personally and totally bums me out because I have a lot of Gore-Tex. I go skiing, I kayak, I do a lot of stuff outside, and I depend upon synthetic clothing and materials to protect me. And sources of textiles. This is probably one of the biggest sources of microfibers in the Great Lakes from washing machines. So we have that. And just from washing one load of clothes creates about 700,000 fibers per load of microplastics. It's amazing to wrap your arms around these numbers. Another problem is that when you use the detergent to clean the clothes, those have microbeads, microplastics. And also when you dry your clothes, the agitation generates a lot of removal of microfibers off of the clothes and again into the environment. Landfills with regards to textile waste is becoming more and more of a problem. We're getting into this mode of fast fashion again, which is reflective of our throwaway society, where these items are only worn 5 to 7, maybe 10 times, and they're thrown away, and they buy some other cheap sort of synthetic material type clothing. So there's a lot of material that's being dumped into landfills. And this is kind of a landfill diagram here. There's several things going on here. One is when the stormwater hits basically the landfill area, a couple things happen. One is the stormwater infiltrates through the landfill pile and ultimately gets collected by a liner that goes into a leachate pond, or the liner leaks, which is supposed to, and ultimately ends up into the groundwater. And what happens also is you get these materials, if it comes into a leachate type pond from the pile, it could go directly into a surface water through some sort of runoff. Another issue is aerial deposition, where these materials are breaking down and the air picks them up and carries them miles and miles away. But don't forget, a lot of the problems with this is groundwater, where you have a drinking water receptor possible who's drinking these microplastics downstream from these landfills. Well, yeah, a lot of research needs to be done on this. And again, it's not being done in the state of Michigan, so they really have no idea of the receptors' impact of drinking the water. Single-use packaging, I mentioned that before. Number one use of plastics, biggest source. Another source is the microbeads, which I've talked about. Cosmetic. An example of it being used is a reflective paint, of one of many commercial applications, and also, again, using it for cleaning operations at an industrial level. Also, plastics are used. The other source is styrofoam, used for basically forms during construction. One of the ones this is one that I think is a very emerging issue, are a thing we call biosolids. And biosolids is basically material that comes from wastewater treatment plants. The stuff that settles down at the bottom is dried. It's shipped many times into agricultural areas, and it's used for soil augmentation and also for fertilizer. So in other words, what will happen is that this material that's all ponded up, dumped off here, basically gets spread throughout the entire agricultural area, which makes it very susceptible to erosion. Just to give you an example, in Michigan, 83,000 tons dry weight of this type of material is spread on a lot of agricultural fields, about 18,000 acres in the state of Michigan. So it's really a huge type of use of these biosolids that contain a lot of microplastics per gram. Agriculture is another source in regards to mulching materials. About 230 pounds per acre of plastic mulch is generally used for specialty crops. But also, microplastics are used to encapsulate fertilizers, pesticides, and seeds. You can kind of think of them kind of like a time-release aspirin that start releasing its contents after a certain amount of time. So ultimately, thousands, if not millions, of microplastics are really released into agricultural fields just by using this particular encapsulation technique. Nurdles. This is an industrial application, and this is really what got me going in this pursuit of microplastics. I happened to find this on my beach in Pentwater, Michigan, and I didn't know what it was. And all of a sudden I started doing research on it, and I found that it was really a precursor to plastic manufacturing. And then I got pissed, and then I started getting involved. And so now here I am being an activist for microplastics. So that's kind of how my story started, was really with this nurdle production. And it's really, it's a really small size that are used by petrochemical industries that are easy to transport, and therefore they're very, very easy to spill into the stormwater system, ultimately ending up on our beaches and in our water. So a pathway, what I mean by pathway is how does it get from the source to the Great Lakes, the surface water? So wastewater treatment plants are very common, a very no-brainer sort of a pathway where material comes in, it's treated, portions of it are discharges, and other material is carried out as biosolids. We have industrial discharges. We have what we call combined sewer overflows, where all of a sudden it gets this huge storm event, and the wastewater treatment plant systems need to basically let the water go into the Great Lakes area. Really a huge concentration of microplastics are released into the water. Just typical stormwater grading sort of pollution litter is another pathway, is really the stormwater system that ultimately goes into tributaries that feed into the Great Lakes. Another pathway from the agriculture is really from stormwater, and it comes from the erosion of these crop materials, the soil. That again, we have biosolids up here that ultimately erode that material and discharge it out into a tributary. This is very similar to what happens also with nutrients, in which the Great Lakes have a huge, huge problem with managing nitrogen and phosphorus because of agricultural field non-point source pollution. And beach litter, a big problem. Again, a very big visual problem for me when I go out there and pick this stuff up and realizing what it's doing. Cigarette butts. Yes, cigarette butts are plastic. Yes, so there's a numerous potpourri of materials that constitute beach litter. The last pathway I'm going to talk about is aerial deposition. I mentioned it a little bit during my talk about Lake Superior, but here is a sample of a picture of aerial deposition of microplastics that was taken here actually in the Colorado mountain areas. But you can see various types of microplastic materials. There's a fiber right here, plastic materials here, here, and here that basically ride upon the wind. And the problem is that here in Colorado also is that it starts to discolor the glacier snow area, makes it darker, and it makes it absorb more heat. Therefore, it makes this area melt much faster than normal. This is a huge problem that the University of Colorado is looking at in terms of changing the flow regimes coming off of the mountains specific to microplastics. Let's get into a little bit of ingestion, a little bit of the impacts. I'm just going to not really give this a due justice. I'm just going to touch upon some of the areas that are going on right now and things that we know and a lot of things that we don't know. The ways of microplastics get into our bodies are several ways. One is dermal contact, such as lotions, cosmetics, etc. But most of it is from an inhalation and also ingestion of food and water. Primarily water is the major vector of microplastics. And this is a startling piece of information. It just came out of Rutgers about a month ago, where they did an analysis of water from bottled water, and there were 240,000 particles per liter of plastics in the actual bottle itself. And to give it some comparison, tap water is somewhere in the ballpark of 4,000, again, depending upon where you get that. They were finding that a lot of this plastic material is coming from inside of the bottle. It's not coming from the actual manufacturing and placement of the water in the bottle. It's actually leaching out of the bottle into the water. Pretty startling, I thought, data coming out of Rutgers. So there's a lot of research that's been done about trying to figure out how much material we ingest. And there's a huge range of plastic that we're all ingesting and assimilating in our bodies. And it's a huge range. There's some researchers say it's anywhere from like 0.1 to 5 grams of plastic per week that we get from the food, water, and air. The main issue here is that we're ingesting a significant amount of plastic, and we don't have anything to say about that. This is totally unacceptable that we're forced to eat, drink, and breathe plastic that we really don't want. So I think it just kind of infuriates me that the plastic industry and people let this go, knowing that we are being susceptible to the various types of impacts that we can have in our microplastics. So I'm going to be talking about really quickly is microplastics chemistry, really quick. When microplastics get into the water, they leach chemicals, such as the things that they were made of before, the phthalates, the PBEs and the PBAs. The things that plastics are made out of, it leaches out into the water or leaches out into the organism that has swallowed this. Another feature that happens is that there has a huge surface area, microplastics, and other chemicals basically jump on board because of the chemical negativity and ionic characteristics that they jump on and have a tendency to concentrate on top of these microplastics. Again, a lot of research is being done on this to really understand what the risk levels are associated with this phenomenon. In terms of human impacts, it impacts in terms of the endocrine system. I talked about that before. It affects our circulatory system. I mentioned that it's gotten into our blood. That is documented, and it affects our reproduction system. So these are the things that we know. We know it's a potential health impacts associated with lab studies. We know that material like microplastics is in the placentas of infants. It's in the meconium, which is really the first bowel movement of a young-born child. It's in there. The infant fecal concentrations of microplastics is a higher concentration than an adult. And so why is that? We have a blood system issue. It gets deeper and deeper into our lungs the smaller the material is. Immune system, sperm concentration and mobility, and creates cell inflammation. In regards to the ecological impacts, I just got 3 areas right now. Excuse me. I got a dog barking. Zooplankton, fish, and birds are really some of the 3 major receptors of this. This picture here is zooplankton. So many of you know this is the base of the food chain for Lake Michigan. And the fluorescent material really is a microplastic. This is a microfiber, actually, that this particular zooplankton has taken in. And you can just see that there's a potential for bioaccumulation because going up the food chain, ultimately to the fish and ultimately to humans. It affects reproduction of fish, of all the types of biota that are in the lake. It's a thing called plastosis, where the gut lining of the fish becomes really scarred, and it affects them and ultimately creates a starvation situation. There's also behavioral changes. There's also and viability problems. So here's just some pictures of some fish, again, mistakenly taking in microplastics, thinking that it's food, again, leading to a starvation situation. Okay, so I'm going to stop doing the doom and gloom. And here I'm going to talk about actual things that we can do. Okay, it's not too late. We can do this. But we have to recognize the fact that it's impossible to remediate microplastics once it's released into the environment. You just can't filter all the water out and be able to collect the microplastics. So we've got to do it in terms of a management approach, improve stormwater management, agricultural controls. I mean, this is not, this is not rocket scientists, so to speak. This is really common sense of what we need to do is to stop the material from getting into the water. Agricultural controls, industrial controls, banning microbeads, material substitution, getting away from the microfibers in clothes, looking at substitutes for tire material, improve wastewater treatment facilities, and stop using single-use plastics. I'm just going to jump to a couple just kind of physical controls that could be done. I mentioned wastewater treatment systems. The thing is about wastewater treatment systems that they aren't designed specifically for microplastic removals, even though they do a reasonably good job in the removal. We have drop inlet water capture materials for industrial purposes to basically collect spilled nurdles. I thought this was cool. It's an electrostatic microfiber tire collector. This is being researched in Great Britain. So anyway, I just thought this was very cool. I haven't seen this as of yet, but basically it's electrostatic material that catches a lot of that material coming off of the tire. Agricultural controls. This is basically using really common sense buffer controls of basically stopping the biosoliid material here from actually running off and getting into a particular tributary. This is things called rain gardens that could be done in municipal areas to try to collect a lot of the litter and material coming off of these municipal areas, off the streets, in stormwater system areas, and ultimately filtering it before it actually gets into the surface waters. We can do upstream controls, such as material substitution. Again, for clothes, we could looking at natural fibers, biodegradable materials. Patagonia is doing a lot of research in regards to looking at getting away from the synthetic materials. We could look at filters that can be done at the back end of a washing machine that basically stops the microfibers from ultimately going into the wastewater treatment system through our sanitary sewer system. And there's various types of machine filters that are out there that can be purchased to stop the microfibers from getting in. I'm going to talk about regulations just very briefly. California is a model for Michigan. They are way ahead of the rest of the nation in regards to dealing with microplastics, from a NERDL law for stormwater management, developing a strategy, microbead bans in the 2020, and even looking at microfiber filtration. So California, just like air pollution issues, are way ahead of the rest of the country. This is something that we're doing in Michigan. Right now, I've been involved with the Michigan Microplastics Coalition, and we have 5 bills that are pending right now through Senator Schenck and also Representative Hood, who are our sponsors for these bills. And we're looking at developing an overall strategy plan, forcing Eagle to start managing these microplastics, starting to monitor it and anticipate impacts, and really start doing some sort of strategy plan. Start doing drinking water monitoring. Again, there's no monitoring that's done to really understand how many microplastics we're taking in the citizens along the shoreline and anywhere in the state for that matter. A microbead ban is another bill that we've got. The microfiber filtration. We have also as another bill. And also we've got a NERDL bill, again, just like California. So we are hoping to get some traction on this regulation, hopefully this particular legislative session. A really quick snapshot of what the federal government's doing. Not a whole lot, but there's something going on. Senator Durbin has a bill called Plastic Pellet Free Waters Act, which again addresses the NERDL issue. There's a Break Free from Plastics legislation that's out there from Senator Murkey. And also, just something that's relatively new is HR 3871, which is really Research for Healthy Soils Act. And it starts requiring to start doing some sort of research on these biosolids that are applied to crops and agricultural fields. This is a slide I put together this morning because it got some relatively new information from the International Joint Commission. Those of you who might not know, the International Joint Commission is really a commission that's developed by representatives from Canada and the United States. And their mission is to manage water quality in the Great Lakes. And it was really surprising to me and maybe to you, there is no approved and consistent methodology in the Great Lakes for how water is sampled, how water is tested, and really how the data is interpreted in terms of risk. These are complete unknowns. And so this is a problem in regards to, so if you've got people in Ohio collecting samples and you're trying to do an evaluation of it in Michigan and try to correlate the two, it makes no sense because they're using different methodologies and the data means nothing. So it's difficult to correlate any sort of data. This is something the International Joint Commission is just recently starting to do, is it created an advisory group to start addressing and developing frameworks that people can go out and actually collect samples and have them analyzed at a consistent way through a consistent methodology that could, again, adds to that consistency from state to state or region to region in the lake. So ultimately, the Joint Commission has identified risk levels of microplastics that affect water and sediment. This is something that they have not published yet, but I have talked to a representative from the Joint Commission. But this is going to do is going to give tools to states to basically understand how they're supposed to monitor and how they're ultimately manage their water resources relative to microplastics. Okay, so what can we do? Let's stop the whining. What can we do? Well, here's something that your environmental organization could do, and probably you're very familiar with these types of techniques anyway, is promoting education and outreach to the public about the problems with microplastics. Contact your legislators about the legislation that's pending, and even your concerns about the impacts of microplastics. I have contact information at the back of this presentation that will be recorded, and so you can basically reference that. I also gave Rachel a PDF of this presentation, which has these contacts. Anyway, these are the 5 bills that I was talking about. Contact Eagle, tell them you're concerned about the lack of microplastic management, and look and support future plastic source reduction legislation that's going to be coming up in the future here in the legislature in the state of Michigan. The other thing you could do is join the Michigan Microplastics Coalition. That would be a great thing to do for you guys. Okay, so what can you and I do? Contact the legislators. Use canvas bags, reusable containers. Don't buy water that's using microplastics, but using plastic materials like single-use plastics. Avoid those. Change your personal decisions about what you buy in terms of clothing, the food that you purchase that has wrapping, etc. You can buy fibers, microfilters for your washing machines. You can use different types of laundry and cleaning materials that don't have microplastics. You can promote better stormwater and management in your cities, promote public outreach and education, and teach your children, teach your friends and your family about the problems with microplastics and plastics in general. Again, we can't recycle our way out of this problem. So finally, I think this is my last slide. You know, somebody comes up to me, I gave a presentation, he says, well, why should we spend all this money on this? You know, we know that plastics aren't hurting us. Well, you know, I really have a tough time with that lack of regressive sort of an approach of management of our waters. There's a couple things here is that we know water is the essence of all things in Michigan. Our economy and our quality of life is based upon water. We've seen, as I give you examples of how we have a poor track record of managing pollutants in the water. Plastics are made from nasty chemicals. They're endocrine disrupting and they're carcinogenic. Things are only get worse at the rate of manufacturing of plastic. 40% increase in 5 years of plastic material. Our $11 billion recreation and tourism economy is at risk if we continue down this road. They're entering us. We're ingesting plastic. Our family, our children, our grandparents, etc., are ingesting the same plastic as we are. Microplastics have been shown to impact fish and wildlife. We know that. No regulatory standards for monitoring drinking water or surface water. I've mentioned that before. So we need a precautionary management approach that's proactive in terms of managing the water quality of the Great Lakes, specific to Lake Michigan and all the other Great Lakes. And finally, the Great Lakes is held in trust to the people of Michigan. I mean, we own the lake. And it's the state of Michigan, like Eagle, who's responsible for preserving and protecting our water. So with that, I'll just have one final remark is that unless someone like you care a whole awful lot, not a lot is going to be done. It just isn't going to get better. It's not. So that's kind of a Dr. Seuss sort of a quote that I'm sure many of you have seen that from the Lorax. So please, I encourage you to visit our Michigan Microplastics website if you want some additional information or if you have any questions, feel free. There's my contact information on this slide. And also, I'll just give you a quick snapshot. Here are the people who you can contact, the House of Representative contacts with their phone numbers. And also here are your state legislators who you can contact also and tell them that you're concerned about microplastics. So with that, I'm really looking forward to a discussion. I look forward to hearing your questions that you may have in regards to the presentation, and I hope I didn't overwhelm you in regards to the information that I gave you. Again, there's things that we can do about this issue, but we have to have the political will and the political will from the people to be able to deal with it. So with that, I'm looking forward to talking to you.
A smattering of applause from the in-person team. Yay. Hello, so now is a great time to turn to the chat, or is there anybody here who has any questions? Oh, yes, hello, go ahead, very good.
With like laundry detergent, I mean, I know it's in toothpaste because I can see it when you can see it on the sink when you spit it out, but.
I'm sorry, I'm sorry. I'm sorry, can you speak up just a little bit louder? I guess I got a bad audio connection. I'm sorry.
How do you know which detergents have microplastics, the beads in them?
Yeah, and on one of my slides, you know what, and I can send that to you, but there is a application that's out there, and you can put that on your phone, and you can look at the barcode. You can zap the barcode with this app, and it will tell you if it contains microplastics or not. That's one way to determine. Another thing is that you can go and look at the label. So sometimes the labels will have it, that have some sort of plastic. It's usually at the very, very back end of the label. And another thing you can do is you could go to the website of your particular laundry, like 7th generation, for instance, or some type of progressive organic based laundry detergent. You can determine if you're using microplastics or not. So that's another way.
Thank you. And question as well? Sure.
Thanks for the presentation. That was really great. Question: with all the sampling that Inland Seas does, can we sample for microplastics as part of what Inland Seas does?
Oh, so is that a question for us, for me?
I don't know.
Yeah.
Well, it all depends. When you're collecting data, I'm an engineer. And so when you're collecting data, you have to ask yourself, what are you going to use it for? Are you going to use it kind of a qualitative that, yeah, it's there, and we see these general shapes, but what is it really telling you? Are you going to do a concentration over time? Are you looking at spatial distribution? So collecting data really depends upon a situation, what they call data quality objectives. Why are you collecting the data in the first place? What are you going to do with it? How are you going to manage it? And how are you going to distribute that? You're going to put it in a paper, or are you just using it for your own edification? So the type of samples you're probably collecting, I think it's good for educational purposes, but being able to identify very, very small, almost like nanoparticles, you're going to have a tough time unless you're using some of these exotic analytical methodologies that are being used right now. The trouble is they're expensive. There's a lot of quality control associated with doing testing because there's stuff coming from the atmosphere. So if you collect a sample or you have it in a laboratory and you're testing it, you might have air pollution problems coming from your ventilation system that's adding more plastic onto your sample. So, I'm sorry for the long-winded answer to the question, but it depends upon how you want to use your data and what you're using it for. Am I making myself clear? Making sense?
I think yes. I had not had the opportunity to talk with Art about how we collect microplastics, and when we do in our programs, we do use a manta trawl system for the protocol outlined by Five Gyres with Dr. Sherry Mason, and we've
Mhm.
worked in partnership with her. And we do have a university partnership that is fully fallen out of my brain. Juliana?
So we currently send our samples to Lake Superior State University. And
Okay,
they
so
have-
that's Lake State University,
Have a lot of the fancy equipment.
and they have the fancy equipment.
Mhm.
No, if we've actually received any information back from them. We do a visual look with our students on board, so we're looking for the ones we can see with our eyes, and then they are doing the further analysis. And as soon as I know more information about that, I'll let you know.
That's great. And again, that's one of the things that the International Joint Commission is trying to do is, again, the consistency of how things are analyzed. So it's, again, like Lake Superior, their 1,000 particles per liter is the same as one in like Ohio or from Sherry Mason's lab, et cetera. So consistency, quality control, quality assurance is a really critical component of doing this. So I think it's great that you've got the analytical capabilities of doing it. I think it's terrific.
Thanks. And a question from Juliana? Oh, no?
I was just gonna add that I think one of the things that they're looking at Lake Superior State.
Do you want to come up here with this, please? More than 5 words, use the mic.
Hello. So I think one of the things that they're looking at with microplastics in Lake Superior State is what is growing on the microplastics too, and how that might be a chain in the biology with it. So,
Yeah.
last our first year partnering with Lake Superior State, so we'll be getting info from them.
Yeah, that's good. And I think there's a researcher at the University of Michigan, and researcher is looking at the growth of pathogenic materials like E. coli or other types of like viruses and bacteria growing on the top of the microplastics. So they kind of complement each other in terms of looking at that type of transport, so to speak.
Awesome. We are rounding 4 o'clock, and I'd like to respect anyone's time and give a thank you so much for coming. Especially my team members sitting here in the folding chairs. So you're welcome to, as long as you're cool. I have a question, but I wanted to say thanks to everybody for coming. You're welcome to hang around if you want to do further discussion.
Sure.
Art,
I'll stay around till there's no more questions or if people want to give their viewpoints.
Okay. I have a question regarding greenwashing. I learned a positively terrifying fact not too long ago. So one of the ways that we are seeing plastic upcycling is in clothing. And I learned recently that there are clothing manufacturers who will advertise that their clothes are made with plastic bottles. And in order for that to be true, they actually manufacture plastic bottles to break down and make their clothes out of.
Oh, that's terrible.
And I'm wondering if you know anything about that or have heard anything, is greenwashing something maybe that we're interested in tackling legislatively? End question.
Yeah, it's a little bit of greenwashing there. That's right. It's like there's this race that happens in Boulder, Colorado. It's called the Boulder, and there's 50,000 runners, and we go 10K every Memorial Day. And what the organization does is they give T-shirts out if you apply. Well, the T-shirts are primarily reused, recycled polyester material. So they kind of tout that as being recycled material. And it is recycled material. I understand that. The trouble is the plastic is already made. I mean, I don't care if you recycle it or not, it's still there. And recycled material, it loses its capability. After you try to recycle material, it loses its properties after the second time you've actually tried to refurbish it. So there's a little bit of greenwashing associated with that. I mean, is it better? I mean, it's still in the environment, you're going to be using it, but it just promotes more and more fossil fuels being generated and creating synthetic clothes, etc. Because if you think that you're recycling it, you'll throw it away much more readily instead of actually hanging on to the material and not throwing it away. So, and also I think like Coke and Pepsi, they said they were advertising that they had these special bottles that it's you're recycling the same bottle that you gave them from what was actually containing the beverage. That was totally greenwashing. There's no way that Coke and Pepsi can basically segregate all their bottles, so to speak, their specialty plastic bottles out and reuse them over and over again. It's just not the way recycling works. So there's plenty of instances in which greenwashing occurs that we got to watch out for.
Thank you. Liam has a question in the chat. Liam, would you like me to read it? You're also welcome to unmute.
Can everyone hear me all right?
Yeah, I can. Hi, Liam.
Okay, awesome. First of all, thanks so much for your presentation, Art. I loved how you included a bunch of information about where microplastic pollution is coming from, but also real life solutions and legislative examples of what we should be looking for. My question was, the Great Lakes are an international body of water. Do you know any information about how Canada is doing in regards to their microplastic regulation? And if so, should we be looking towards them as an example of how to move forward legislatively?
Good question. They're struggling. They're struggling just like the United States. They started to try to put some sort of constraints on plastic manufacturing. And what they wanted to do was they wanted to identify plastic waste as a toxic waste material. And they got that through the legislature, and so they were able to stop it at the source, if you will. And that was really an accomplishment until it went through the court system in Canada and it got kicked out. And I think a lot of chemical manufacturers had a lot to do with that decision. So they're struggling just like we are in regards to how to manage this in terms of legislatively. Again, I think I'm optimistic that something will happen, but I think Michigan could be a real leader in this in regards to starting to do something about actually developing plans, banning certain types of microplastic materials, and really promoting another alternative that could be done. Like for an example, we one of our bills is called, I mentioned, was filtration. Filtering the microfibers on the back end of a washing machine. In our bill, we're proposing to give people who are interested, $150 to $200 just to buy this filtration unit, so they'll put it on the back end. So again, I think these are laws that other states have looked at, like California. And I think that Canada has also looked at the filtration requirements. But again, I don't see a whole lot of strong legislation coming out of Canada as of yet. But I want to mention Canada because, they do a lot of research there. The University of Toronto is great. I know the work that Sherry Mason's been doing in New York, where I think she's been doing a lot too. So again, Canada is just as concerned as we are.
Wonderful. Thank you so much.
Hey, Rachel, would you ask Art if burning plastic at very high temperatures is effective?
Yes.
I'm sorry.
I got you. I'm repeating it back to you. So a question in the in-house is burning plastics at very high temperatures an effective means of dealing with the waste?
It's called chemical recycling. And that's a term that the chemistry association uses. There's a couple problems with that. Is that, they try to, probably the biggest, there's two things that come to my mind, the problems with using that, of burning it at a high temperature is called pyrolysis, is one that there's an enormous amount of greenhouse gas emissions that are associated with that particular practice. The second thing is that there's dioxins and other types of chemical, air pollutants that also come out of that process that people can be exposed to, the environment exposed to. Also, when you start getting into the oily substance, there's very few applications that are associated with the end product from the pyrolysis, and it generates a lot of residue. And what do you do with the residue? It's toxic material, and so it has to be treated as a toxic waste. So there's a lot of problems associated with the chemical recycling, and it also gives an excuse for fossil fuel industries to keep manufacturing more and more plastics, where we need to be stopping that or significantly reducing it down.
All right, anything else from either crowd? Neat. Art, oh wait. Hi, sorry.
I'm not familiar with the term greenwashing. Quick definition would be helpful to me.
Sure, quick definition of the word greenwashing. And I'd love for us, actually, I would love for both of us to give a definition if you're cool with that. On my mind, greenwashing is when there is an organization who is using probably untrue facts to make a consumer feel like they're purchasing an environmentally friendly product, when in reality, they just they put a bottle on it with a recycling arrow around it, but it's still made out of plastic. So that kind of is what greenwashing is. And expert definition.
Yeah, I think that's pretty close in terms of my definition too. It's misleading the public of how great and wonderful a given company is when they aren't necessarily so great and wonderful. And they're not necessarily doing the right environmental thing. They're misleading the public to try to improve profits, to continue the use of fossil fuels. So that's kind of how I see it.
Awesome. Cool. I love that we were pretty close. Yeah, thank you. All right. Well, in that case, thanks so much, Art. We're gonna today's meeting, and just we have our volunteer on March 15th, and that's from 4 to 6. And I have not started calling out to ask for help yet. So if you're interested in helping out, let me know. And if you're not, I'll probably call you anyway in a couple of weeks. And I'd love to see you all there. And yes, and if you are a returning volunteer team member, we do have our returning volunteer meeting tomorrow from 2 to 4. So looking forward to seeing everybody at some point soon. And Art, thanks again for coming out. And
I'll see you next summer.
yeah, absolutely.
Thanks a lot, y'all.